All right, this will be my second take, so to say, on permutations and on the Smurfs. I already recorded quite a bit there. It took me quite a while to do that, but I figured I'm starting over again. All right, so here it is. So this particular section is going to be on permutations. My first comment over here is something about videos from the Tokyo Olympics and from the London Olympics and the US trials. And I'm going to do that actually toward the end of this entire lecture. I also am going to do something with Smurfs here very soon. All right, so let's look at this one here. So here's a heat in swimming, and they already have the questions and answers for us here. So they say, okay, how many different podium placements, first, second, and third place, are possible when the final heat of the Olympic swimming events features 8 swimmers? And the second question is, how many different complete orders of finish, first place through eighth place are possible? So the first one, when you read through this one here, is that you can choose any one of the 8 to win the gold medal, but then you have 7 left to win the silver medal, and then you have 6 left to win the bronze medal, and that, of course, is from the previous section, which was the multiplication rule for counting. So you have 8 times 7 times 6, which is 336 different ways. Now, when you go first place through eighth place, well, you're going to start the same way. You choose 8 first, and then you have 7 remaining, and then you have 6 remaining, and then after that, you're going to have 5 remaining, 4 remaining, and so you multiply them all together. It's 40,320 possible orders of finish. And at this point time, I'm going to turn it over to the Smurfs. All right, so the swimmers, turns out actually I don't have any swimming Smurf. Maybe I couldn't find the one that I do have. So you're skiing, golfing, bowling, soccer, football, apparently sledding. Notice that for the fencer, something is missing there. The skateboarder, something is missing there. Some of these Smurfs, by the way, are 50 years old from me playing with them, and then 10 years later, my sister is 10 years younger than me, so she played with them, and she was the one who got rid of like the skis or something, or the sword there and that kind of thing. So here we have these 8 athletes that are standing in for the 8 swimmers, and the question is, how many possible ways can you have gold, silver, and bronze medals? So out of these 8 here, you choose any one of them to win the gold medal. So here the bowling Smurf, for example, and you have 8 possibilities. That's it for the gold medal here. And then you choose 1 out of the remaining 7 for the silver, and there he is. Could be any one of the others here as well. So 8 times 7 possibilities, and then you choose any one of the remaining 6 for the bronze medal. So this one here, and so you have 8 times 7 times 6, those 336 combinations. Now, for all possible places 1 through 8, when you do that, you choose 1 out of the 8, so it's 8 possibilities. 7 are remaining, so it's 7 possibilities. 6 are remaining, so it's 6 possibilities. 5 are remaining, so it's 5 possibilities. 4 are remaining, so it's 4 possibilities. 3 are left, 2 are left, and then 1 is left, and now you have places 1 through 8, and the possibilities are 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So these, I believe it was 40,320 possibilities when you put that into a calculator. And talking about calculators, let's see if I can hold this on the camera here. So here's the 8 times 7 times 6. There's the 336. And then the other one here would be same thing here, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that is that 440,000 320. You may not have this calculator or scientific calculator. Will also do sometimes, I guess, your cell phone, respectively, the online calculators that I will show you. Before I move on, by the way, here's the bowling Smurf. If you Google my legal name, which is Andreas Fee, and you put the word bowling behind it, you will actually come up with something for me with, because 40 years ago, I was a pretty good bowling player in Germany. All right, let's move on. So after showing us with the Smurfs, let's go on here. So here you have other examples. So if you take 5 cards, and to how many different orders can you put those cards? Well, you have 5 choices on the first, 4 on the second, 3 in the next, and so on. So you have 5 times 4 times 3 times 2 times 1. If you do that, you come up with 120 possibilities. Well, it turns out actually that for a royal flush, it really doesn't matter how you hold the cards. So you can arrange them in 120 different ways, but really all that matters is that you have them, which means the one combination actually is good enough. Combination, by the way, will be a word that we use later. Okay, so here they're trying to tell us, hey, let's have a few calculations here, and they introduce a new word, which is factorial. And that exclamation point here is factorial, and what it means is 4 factorial, right here, 4 times 3 times 2 times 1, equals 24. I sometimes write it in the opposite way as 1 times 2 times 3 times 4, which is also 24, and that's because multiplication is commutative. It doesn't matter in which order you multiply, and the book is really consistent on that by doing that, but you will very soon see that I sometimes have a little bit of an agenda there too, to start with the 1 times 2 and so on. So here's one example, for example. A family, mother, father, and 4 kids arrange themselves around the dinner table. Each evening, they use a different seating order. How many days, years will it take to cover all possible combinations? So for this factorial, back to the Smurfs. So I'm going to do the factorials first, and then I'm going to do a dinner table. So here's the factorials first. I have 1 Smurf. There's only 1 arrangement that I can do with this 1 Smurf. Now I got 2 of them, and there are 2 arrangements. As such, and as such, 2 arrangements. Now I take a 3rd Smurf. How many arrangements do we have? Well, factorials now is 3 factorial, which is 1 times 2 times 3. So I have here, which is 6. So I have here 1 arrangement. That's the 2nd one. Now I'm going to put this guy in the front. So that's the 3rd one. That's the 4th arrangement. And now I finally put her in the front. That's the 5th arrangement. And that's the 6th arrangement. So 1 times 2 times 3. If I take a 4 Smurf in here now, 1 times 2 times 3 times 4 is 24. So 4 factorial, which is, by the way, why I sometimes do start with the 1 times 2 times 3 and so on, while the book is consistent the other way around. So here I'm supposed to have 24 arrangements, right? So now what I could do is I could show you all these 24 arrangements, but here's the thing. I already know that when I have 3 lined up here, I have 6 possibilities. Now I'm going to put this one here. I put him in the front, and I still have 6 possibilities with him being the front. However, what if she's in the front? Again, I have another 6 possibilities. Well, what about if he's in the front? Again, I have 6 possibilities. And finally, what if this guy is in the front? And again, I have 6 possibilities. And so any one of these 4 can be in the front, and then 4 times the 6 that I had a moment ago is 24. So it's 4 times 3 factorial, which is 4 factorial, which is 24, which means when I put a 5th Smurf here, there you go. So now I have my 24 here, and then with the 5th one, any one of these 5 here can be in the front, so I have 5 times 24 possibilities, which is 120. 5 factorial, 120. If you play it out, you get 120. Notice that I'm not going to take the time to do that. And here I have a 6th Smurf. So now I'm going to have these 120 here already. I put a 6th one here, and then any one of these 6 can be in the front. And I have 120 possibilities each time for any, oops, he's supposed to be in the front actually, for any one of these 6 Smurfs to be in the front, 120 possibilities. And there are 6 such Smurfs, and finally him in the front here. So 6 times 120, 720, which is 6 factorial. All right, so that is the factorials. And this is how you do it on the calculator, respectively. It's actually really easy to do on the Google calculator or on other online calculators. So here I have 1 factorial, and I actually have to find it. I know where it is. There it is. There it is. There's that exclamation point. There we go. And I hit enter. 1. Fix that to a 2. Fix it to a 3. There's 3 factorial is 6. Fix it to a 4. 4 factorial is 24. Oops. I actually meant to hold that up here. It's quicker. 5 factorial, 120. 6 factorial, 720. And then this one we didn't have yet. So 7 factorial. And then this one here is the 8 factorial, which we actually already had. That was when you take all the 8 swimmers and you arrange them in any possible way, 40,320 possibilities, 8 factorial. And then, of course, you can go on. You can go to 9 factorial. You can go, this goes really fast high up. So here what I could do is I could, for example, I haven't tested this, 18 factorial. Wow, that's a 6 there with 15 digits afterwards. All right, dinner table. These possibilities, which is a factorial. So I didn't, okay, I said family, right? So instead of father, mother, I have grandpa and grandma Smurf. And then I have, I guess, 4 grown grandkids, and maybe this is a smaller grandkid. So how many different arrangements could you have around the table? Well, it's the same as before. So you start with this one here, and then you swap, let's say, the last 2 out. So here's the second combination. Then you do it with this one here. So here's the third combination. I guess my baby Smurf is falling over. And then you're going to swap this one off here. So yeah, that's the 4th combination, I believe. Then you put her over here. That's the 5th. And then this one is the 6th. Now you have these 3 here at this first 6 combination. That's 3 factorial. Now you're going to get her in. So you're going to switch over here and then again around here, and you come up with 24 when you're all done. And then you take him into the equation and you come up with the 120 possibilities. And finally you come up with the Hook Smurf. Then you get the 720 combinations or days or 2 years approximately. So that's factorials. You just multiply 1 times 2 times 3 times 4 and so on, and that would be 4 factorial, for example, or times 5, 6, 7, 8 factorial, that kind of thing.